Okay, in this reading, in this lab here, let's go straight to the experiment. We're going to be using a multimeter so that we can measure the current as well as the voltage of each thing in the experiment. We're going to be using 3 brand new cells. Although they should all have 1.5, we'll be taking the reading of each one of them so that we can make sure that that's what we have. So we are not just going to take with what is on the label on the battery as to say 1.5. Okay, it states here 1.5 volts, but not necessarily it may be, because this was at the store. So we're going to be looking at those ones there, and we're going to be using a few wires. I had to borrow these wires from another high school here in Belize City so that we can do this experiment, as the equipment was not at school when we wanted to do our lab. And also we have fallen behind in the sense that we were not given permission to come into a compound on Monday when we had already planned to come in on Monday to do certain labs as well. So let's proceed with this one here. But before I proceed with this lab, I must make sure that these wires are complete. Although they may seem complete, that doesn't mean that they may conduct current or electricity, in other words. So I'm going to be using my multimeter to test continuity first of all. Okay, so I turn this to this point, and if it is complete, then the connection should make a humming sound, so like this. Okay, so I'm going to test from end to end of that same wire. Make some little space here, as space is limited right now. So all these things are factors which you need to take into account to see if it's complete or if it's not complete in the experiment. Otherwise you may make mistakes and may be struggling to figure out which one is the issue. So testing here, okay, it's complete. So this wire is good. We have one of the wires. Let's test this red one here as well. This red one here. Okay, you get a reading. Okay, good. It makes complete. It's complete. We're just gonna make sure that all the wires that we might need are complete. Okay, so it makes that sound. That's complete as well, and we're gonna make the circuit as simple as possible. So that's complete as well. So now I'm gonna measure my voltage of each one of these cells, and I'm gonna be labeling them as well. So I'm gonna put here cell number 1 volts, cell number 2 volts, and cell number 3 volts. So I have labeled them also here on the side as to say 1. Okay, so let me make space here so we only have the cells to measure with, and I'll bring the multimeter there, which is measuring voltage. I'm going to keep it at that point, and it measures 1.57. It's kind of strange. It should have been 1.5 volts. Don't worry about the negative right now, okay? Just work with it. 1.57, 1.57 for number 1. This is battery number 2, as it is labeled there. So let's put that also to its measurement, and we get 1.40. Okay, 1.40. And then we measure battery number. I have put this number 4 because I had found another one, and the other one wasn't that good, so I pre-tested them also as well. So that's 1.4. Okay, so we have here 1.4. So our goal here now is to have the different measurements in a circuit. So we're gonna have our power source. Okay, so I'm gonna put here I'm gonna put my ammeter. I'm gonna put here our device which we are working with to find what's happening, and then we're gonna bring it straight across. our switch will be simply just to close it and make our circuit complete. So here is where will be our item. So we're going to find a relationship with just current and voltage. All right, so that's our circuit that we want to complete. Our voltmeter will stay here so as to make sure, I mean, the amperage, the volt will be here already, so depending on what we are actually adding, we will have our volt, so we don't have to measure the volts. The instrument to measuring the amperage will be set there. Okay, so we're going to be having our meter right here, which will be taking reading of what's happening in this item here. So this could be any item that we can find at home. So I'm going to have this now start off by assembling, set our meter to its correct position right there. I'm going to change this to 10 amps. All right, so I'm going to just put this here, keep some of the wires of the ammeter out of the way as well. I'm going to put here voltage V, current here as A, and I'm going to make my column right there. Okay, and I'm going to put my first cell, which should be, we said the first cell was 1.57, so we're going to put 1.57, and when we add on the second cell, that will be 1.57 plus 1.40, and that should give me 1.91 volts. And then I should add the third one, so it's going to be 1.91 plus 1.44. If we had a rheostat, we could have used this. Again, that wasn't at the school when we wanted to do this lab here. Okay, so we're going to add this. I have here 5, 13, 3, so 3.35 volts. So we have 1.57, 1.91, 3.35 volts, and we're going to find the current. The utensil that I'm going to be using is a basic butter knife. All right, so I'm going to put here my butter knife. I'm going to try to keep here as much as possible clear. I'm going to be assembling our circuit. The power source will begin from cell 1, which will be here. That will be connected to this section of our item. Our voltage will be remaining constant, as how we said that, since we already know what are each cell. So I want to put here now my positive terminal to this item. We already know it's a butter knife, but this could have been used any other item that we want. We're not taking the length into consideration. I'll put the item right here as well. I'll keep our reading. Okay, space again is a little bit of a challenge, right? And so we have the negative end to be connected right here. Okay, so we also need a negative from this side to come to our battery right there. Okay, oops, sorry about that. I mean this to be connected to the section right here, so my mistake right there. So connecting it here, so it's going to complete to our meter. Okay, our voltage will be our current will be coming from the negative going through here and back again. Remember, this is measuring our amperage, so that's what we want to find out. So we complete our circuit by coming here to the, where's the other piece here, negative ground here. Sorry about that. I'm trying to keep eye on the camera as well. Right there, comes here, completes our circuit, and so we would then end up with this. So we have one more wire to connect up, and this is what would then happen. Okay, we see our reading now. That's all what we need to do and take our measurement. Remember, this is the 1.5 voltage, So we take our first reading. Don't worry about the negative, it just means the polarity, how we have set it up. So when I take this measure, I'm going to measure what's my current inside of it, of this one here, to 2 decimal places. So when I do that, I end up with, when you see stationary, fix this a little bit better. .0.3.5. So it's 0.35. Okay, so we have that. I have to make sure that nothing is getting loose here. Is that okay? Okay, that okay. Okay, here. All right, so we have that piece there. So after this one here, I'm going to take the second cell. I'm going to connect it in series, so we are adding the amount of voltage. Okay, again, let's make sure that everything stays good. Oops, I don't want this to be crossing, as there is a magnetic field there as well. So let's work with it this way. So we come here now, connect it to our knife again. Okay, our butter knife. We want to know, again, this could have been done with anything that you want. Okay, I am using a butter knife because I think that's something that everyone should have at home, and so that would then help us. So let's make space here, and so we have connection there, and I'm going to connect up the cell now. So let's see what's our reading this time. Remember, the voltage has increased. It's the same length, same everything should be. So I want current increase to 0.55. Let's put 0.55. Okay, now I'm going to take my I'm going to take my third cell here, which is labeled number 4. We've already added on the voltage, so that's one of our limitations there. So put it there in series, and let's see what then happens. .32. So we have 0.32. That's kind of strange. In the meantime, let's write it down before we forget it. 0.32. Let me go over everything that's connected here. Let's make sure that nothing is joined or loose. All right, everything's connected there. In series. Connect. Zero point three five. So now that's kind of strange for it to come here. Okay, so let me go over this one here a little bit more. Let's go over this whole thing. This with the first one, confirm our readings. .3. Second one, 0.54. First one again. Okay, and so with the third one, take our measurement there. Okay, so let's increase the record even smaller current. We have 4.5. So I want to use here 4.5 when you're measuring even much more precise. Milliamps to 5.9. Okay, and I'm going to put in the third one. 4.2. So we went here to 4.2. Okay, that's kind of strange there. So we're going to take another one. I'm going to use this next one here. I'm going to find out what's the voltage in a little while. So I'm going to connect these 4 of these right here and see what then happens. Let's keep here everything connected. .5. So we'll call that one there 5.5. Now where's my pen? 5.5. And let's go over our voltage of each one of these cells here as well to make sure that we have done them properly. I'll disconnect from here, here, and oops, this went bad. And this cell is the only one which we did not do. So I'm going to measure this one here before we mix them up. 1.26. So we have here 1.26 plus this one here. Then we have 4.51 volts. I'm going to measure the third cell as well over to make sure. That's our voltage of 1.44. 1.33. Okay, so number 4 is 1.33. Could not have been lost so much voltage. And now I'm going to measure number 2. 1.33. And then I'm going to measure number 1. 1.52. So everyone went down by a few hundred of volts. So these are our readings. We're going to be using this set of readings to be plotted along with the set of readings. Okay, so our graph will look like this roughly. Have volts here and amps here. Okay, so we're going to be plotting those points on a graph paper. So let's take out our graph paper and let's start to do our labeling. So to capture as much as possible, I'm going to start from here, which is 0, and I'm going to say 1 volts. Now this is 1 volts, 2, 3 volts. It's going to be a bit of a challenge, but nevertheless we're going to get as much as we can get complete here. So you have here, now when we say 1.52, it's 1, and we go to the 5th set in between. Okay, so we're going to be dividing this into pieces, which is going to be every 2 little millimeter is going to count as 0.1. This, and then once we get inside, then we get much to the second place centimeter. And so we go here up to 5. We're going to have here 1, 2, 3, 4, 5. So I'm going to take, fold this over so it can fit on our graph paper, and I'm going to draw my lines. And I'm going to plot my points as well. Okay, so it says here 1.52, so it's 1.5 will be in the middle, and so 2 afterwards would be, we have 20 every 4, so we have here 4 here, as you can see. Let me zoom in so you can see much better. I have here 1.54, we want 1.5 to 1.5, and we come right in between here. So that would be for the voltage, and then for the amps it would be 4.5. So we come here to 4.5, 4.5 approximately right here. Okay, I'll put here 6 here, but that we should have continued a little bit more. And then we go to 1.9, 1.9, that's almost the last one. 1.9, 1 here, and we plot our points.